Hello everyone, this is Taras Voloshin from SRI-TUS, and today I'm going to talk about the generic widgets framework we have developed here at SRI. The goal of today's video is to create a basic data provider, a basic view provider, and a mapping provider for it. But before I do that, I would like to talk about the three main concepts of the framework so you can easily follow along. So the three main concepts of this framework are the following: the view provider, data provider, and mapping provider. The view provider is essentially a representation of your data. So that can be a chart. So you can show, for example, different data sets, how they compare one to each other. It could be a table, which is just basically read from the database or from a file from the logs, for example, and etc. The data provider is essentially a provider of the data. Now you have to bear in mind that one data provider is not one source of data. So essentially the idea is that inside your data provider, you can run multiple requests, fetch the data from multiple sources, and potentially combine it into one object, which is then being fed to mapping provider, and from mapping provider to a view provider. So as you can see here on the presentation, data provider provides data for views from various sources, such as API, database files, etc. The way framework is designed is essentially you can create your own custom data providers, which are then can be easily integrated into existing view providers by defining appropriate mapping functions inside mapping provider. Mapping provider is essentially a class which contains either one function or multiple functions depending on how many conversions you want to do. So you could have a one-to-one conversion, for example, from one data provider to one view provider, or you could have, for example, a conversion from one data provider to multiple view providers. Or alternatively, you could have a conversion from multiple data providers to one provider. So essentially it's many to many, one to many, all of those combinations. Now, you might ask a question, why do we have a mapping provider and don't have the actual conversion function inside a data provider? The reason we have done that is because we didn't want the developers to write a data provider for each single view provider. So essentially, if you're talking to the same API, but you want to represent your view, let's say in a different format. So for example, you could have a data being read from database and then represented in form of a chart. So let's say if someone came in and had their own view provider and then they decided, for example, to use their data provider, they don't have to rewrite it. They don't have to, extend it and create multiple classes. So essentially, once you create a wrapper around API, that's enough to get people to use it. So mapping provider is this bridge between view provider and data provider. So technically, if someone has created a data provider, let's say for some weather API, and let's say that weather API is being represented in the form of a chart, if someone decided at a later stage to create a table view or maybe a nice little widgets with clouds and suns images, they can easily do that by defining their own mapping provider without the need to have to rewrite or extend or do anything with the data provider. Now, another main feature of the framework is the editors. The editors were designed to allow end users of the system to customize certain features either of a view provider or a data provider. In case of a view provider, that could be, for example, change the chart type from bar chart to line chart, maybe modify the colors, etc. In case of a data provider, that would be the actual query builder, for example. So if you wanted to search for something within the database, or maybe if the user has to provide a database name or table name and then query for certain rows or certain fields, that's where the editors come in place. One thing to note is that the editors are fully customizable UIs, so the developers can essentially write and structure the views the way they want it. So for example, if it's a plain text input or text area to collect an SQL query directly from the user, you can have that with a simple send query button. Or if you wanted to go and create something more advanced, you can create a list of selects, for example, for database name, table names, or for example, you could have a Google Maps component where you drop a marker to get the location and maybe display weather information, etc. In this tutorial, we're going to create a basic data provider for metaweather.com, which is essentially an aggregation weather API, which doesn't require any key. Now, this is only used for demo purposes. Obviously, you don't have to stick with it. You can change it to whatever you like. Then we're going to create a mapping provider for existing view providers, in this case, Chart.js. So we're going to create a simple, essentially, mapping provider, which is going to take the data from the data provider and convert it to a bar chart. So in this case, we're probably going to use, difference in temperature over the next 5 days. Then we're going to create our own view provider. And in order to connect the two things, we're going to extend our existing mapping provider so it works with Chart.js and our newly created view provider. So what are we looking at here is essentially the folder structure of our project. This is basically an Angular application, and we use Angular CLI to generate the project. And then essentially what was structured inside the app folder was done by us. So the components is essentially components used by Angular application. The only one you'll probably be interested in would be the dashboard, which contains the actual framework specific components called dashboard grid and dashboard widget. I would like to make a note that those components can be easily changed. So if you prefer to change the styling, or if you decide to completely rewrite it at a later stage, how you render the widgets and display it, you can easily do it by modifying those files. Ideally, you probably would never have to touch it. All you have to care about is declaring your own view provider, declaring your own data providers, mapping providers, and those things can remain unchanged. So as you can see, we have a data providers folder which contains our data providers. And as you can see, there are multiple ones in here. We're going to create our own, obviously, and I'm going to show you how to do that in a few minutes. Now, inside an individual data provider, we have essentially a data holder. We have the module associated with that provider, and we have a service, which is essentially an implementation of the data provider. It is highly advisable to keep your data providers and all associated files like the editor, for example, and the service inside a module. The editor itself is basically an Angular component which has CSS, which has its own HTML and a TS file. The lib folder is, you could say, essentially a framework itself. It contains files for the data provider model, so the actual interfaces for view provider, for mapping provider. It contains providers registry, so this is how essentially how you register your data provider, and then it becomes available to entire application. Same applies to view providers and mapping providers, so you don't have to go and change any HTML code or whatsoever. For this purpose, we use decorators, and I'm going to show you how to create one in a few minutes. The mapping provider folder contains the mapping provider. As you can see, we kind of stuck with the naming, saying from what you're converting, so essentially from what data provider to what view providers. Now, this structure could change, and maybe it could be categorized into folders, depending on how project progresses into the future, and also depending on number of mapping providers. The view providers folders follows the similar structure to a data provider. Obviously, with the one exception is that view provider itself has its own HTML, its own TS and CSS, and then editor folder pretty much remains the same as with data provider editor. The rest of the files are standard Angular files, so if you want to look up how to structure Angular application or how they're essentially structured, you can find the relevant information on the web. Okay, so now that we know the basic structure of our application, we should probably create a data provider. As you can see, I'm using Visual Studio Code, so it has a little handy plugins for helping me to generate, the standard Angular component structure and module structure. So for the purpose of this demo, I'm actually going to use it. As you remember, I said it's better to keep everything inside the module because, depending on how complex your data provider is, you might have, multiple components inside, let's say, your editor view, and you probably want to encapsulate them, inside a module. So then if someone else was to use it, or let's say include in their data providers, they don't have to worry about including each individual file. They can just include your module file. Okay, so I think this is time to create our first data provider. And for the purposes of this demo, I'm going to use a little plugin to generate all the necessary files for a module. It's essentially a one file thing. You can look it up in Angular documentation, how to declare a module. But as I said, for the purpose of this demo, I'm just going to use this plugin, and we should probably give it a name. And let's say to keep it consistent with the way everything is structured, we use DP for data providers, VP for view providers, and MP for mapping providers. Now, because we're using a MetaWeather API, we probably should call our module MetaWeather DP. Now, this plugin seems to be generating additional files, which I'm going to remove now because I don't actually need them. We are creating the data provider, so technically we don't have any CSS or HTML. So as you can see, we opened this file, it already gives us an error because that library has generated a component. We basically get rid of it and the error goes away. Now, so the next step would be to create our data provider. Now, as you remember, I have mentioned that we created as a service, and the reason for that is because we want to inject it into our components, and the idea is data provider is used across entire application. So technically, instead of creating, every time a new instance of a data provider, you just declare it once, and then it's being injected using dependency injection of an Angular. So now that we have our module, let's create an actual service. Now, the reason we create a service is because we need to inject our data provider inside our component. And in case our data provider needs access to something like, let's say, HTTP client of Angular or any other specific services from Angular, we can inject them inside our data provider service. So let's create a new file called MetaWeather DP service TS. So what we have to do here is create a class, and let's call it MetaWeather data provider. Now, one important thing we have to bear in mind is because we're using Angular, we have to declare this service as injectable. So this basically means that Angular can now inject it using the dependency injection built in to Angular framework. Now, the next step would be to implement a data provider interface. And as you can see, we already get a warning saying that it incorrectly implements our interface called data provider. So I'm going to use a short code inside Visual Studio Code to generate all the methods, something similar like Eclipse does when you click and let's say generate implement interfaces. Okay, as you can see, it has generated methods for us. Now, it's probably important to understand what are each of the methods. So we probably should head to the data provider interface and I'll be able to step through them. Now, as you can see, the first method is the query method, which accepts the params. Now, params could be essentially anything, your custom object, and essentially anything you want. Now, a return type of this is observable. So this is done in case we need to run a network request and, essentially the code isn't synchronous. Now, the next method is called test data provider, which essentially tests the data provider whether it's ready to accept the request, so whether it can be queried. And for example, we could say that if it returns false, we might as well check what is wrong with it. So for example, let's say if it's a connection to a database, maybe it requires username and password, or if it's a connection to an API, maybe it requires token. So technically, before you make any queries, you should test whether your data provider is ready. Now, next method is called getDataType, and essentially each data provider has its own return data type. So it could be a holder, which let's say contains the structure of an API reply. Now, by saying holder, I mean class. So for example, you can declare a class called my provider data holder, or maybe weather provider data holder, and inside it you can declare different fields you expect your data provider to return. So let's say if you're designing something against an API, you probably have a standard return model, like for example error result, and then your result could be anything, depending on your query. Now, getDataType is used by mapping providers. So in order to determine for the widget whether it actually supports a data provider, it has to know what is the data type of that data provider. So this way we can actually do a match to say, okay, if I'm, let's say, selected a view provider called char.js, and char.js has its own getDataType, and let's say that data type is char.js data holder, and for data provider, let's say in our weather one, we could have that it's MetaWeather data holder. So the mapping provider would then implement two of them and say, okay, I'm actually supporting the mapping from char.js data holder to MetaWeather data holder. And then we can assure that, okay, I'm actually selecting this provider and there is a mapping provider for it. Don't worry if you didn't get anything, I'll be explaining that as I write the code, and hopefully you'll gain a better understanding of what is used for it and where it's used for. Now, the next step we have to do is register our data provider, and we actually have to do it in a few places. One, inside our module. So Angular is aware that there is a data provider, or in this case, in terms of Angular, it would be a service. So we have to declare another property called providers inside ng module decorator. And what we do next is essentially we import our MetaWeather data provider, which also happens to be a service in terms of Angular. So as you can see here, I've imported my MetaWeather data provider. Now, the next step we could probably do is move up the chain, and inside our data providers module, we could import our meta weather DP module. Now, so what we have done so far is essentially we created a data provider, we registered inside the Angular, we register inside our module, and then our module get registered in, let's say, a global module for data providers, which is then registered in the app module of entire app. So it essentially moves, up the chain as you go. And this way, we don't have to go and declare every single data provider, view provider, and everything inside our app module. So app module technically imports all the data providers module, which, if we follow the link, contains all our module of other data providers. And as you can see, we have meta weather DP module in here. Now, the next step would be to actually register our data provider inside a registry, our registry, which is an internal registry of a framework, you could say so. So in order to do that, you have to call a very special decorator called data provider declaration. Now, what the data declaration expects, there is certain fields essentially you have to fill in before you can say that your data provider, is ready to be used by other users. Now, there are a few fields that have to be supplied. One of them is an ID, next one is name, and then data type. Now, as you can see, the other properties are marked with a question mark. They are essentially non-essential and should only be supplied if you are intending to provide, for example, editor view or provider config defaults. Now, even though provider is set here as optional, it's actually used internally in order to declare your class. You can learn about more how decorators work, and ideally, it's only used for read purposes. So let's actually declare all the properties one by one. Now, the ID has to be unique, so you have to bear in mind that if you do end up editing the same name, the app will throw you a warning that it cannot register a data provider because a data provider with that ID already exists. To keep things simple and follow some sort of convention, we decided to use @ DP dash and then actual name of your data provider. So let's say in this case we're gonna call it meta weather. Now, the next property it expects is the name. The name property is essentially a name of your data provider, and it determines how your data provider will be displayed inside the UI. So for example, if you want to say meta weather, you can use spacebars, you can use dashes, you can maybe include your name in it if you liked it. So it's essentially a custom string. So your ID is uniquely identifiable, whereas name is non-unique. Even though the name is not unique, you'll still be given a warning because your ID is different, but if the name has a collision with existing data provider, what happens to the end user, it might look like the same thing, so they could accidentally click a wrong data provider. So technically and practically, to keep things simple and don't cause confusion for the end user, you probably should use a different ID. Well, obviously, you have to use a different ID, but you have to use a unique name for your data provider. So we're gonna keep it simple and just call it meta weather. Now, the third property, which is mandatory, is our data type. As you can see, you have a data type in here. And as you can see, they are a bit different because get data type inside our class is being used during the dynamic initialization, whereas this is, you could call it probably a static initialization because it's only being initialized once. So what happens is that inside the registry, in order for us to find a correct mapping for your data provider and for your view provider, we have to know what data types it supports. And the way we do it is that once you declare it in your data provider declaration, it's being stored in the register, and we could perform a basic search. So the class names returned by the data type here and get data type should always be the same. Now, obviously we haven't created one yet, so maybe let's go and create our meta weather data holder. So I'm just going to create a new file called meta weather. And inside that file, we're gonna have a class called meta weather data holder. Now we can leave it blank for now as we haven't looked at the API yet. So the reason we have created it just to essentially keep this declaration happy. So we essentially copy paste and reuse the same class name in here as well as in here. Now that we have declared our data provider and have used the declaration, proper injection and everything, we could actually see it being added into our widget framework. So if you look here and let's say try to create a char.js widget, so in this case the view provider will be char.js, and if we go and try to edit the widget settings, we can see that here we have our meta weather provider. Now, if you click, you see nothing happens because technically we still don't have a mapping provider, so we can't really fetch anything. And then we don't have the data provider editor, so we can't really build a query to fetch something. So probably this is something we should do next. But before we do any mapping, we should probably implement our functionality of our data provider. So we're going to look at the MetaWeather API, see what queries it supports, and then we'll be able, to create our mapping provider once we can actually fetch the data. So if you look inside our MetaWeather API documentation, we can see that it has a very straightforward API. So you have a query method, which essentially allows you to search the place by name. So as you can see here, it has London. So it returns to us the title, the location type, and then it has this WOI ID, which essentially stands for Where on Earth ID. So it's kind of like a global identification used to determine the location. So as you can see, once we have an ID, we can then actually send a request and query our data. So in this case, here you can see we are making a forecast for London. And I actually have prepared, more user-friendly and readable version of it using the JSON formatter. And as you can see, this is our response object from the API. Now, the properties, just for the purpose of this tutorial, we're interested in are the temp. Maybe we could use minimum and maximum temp to, show the temperature difference. But I'd say let's have a very basic one. So, we have our dates, we have our temperature, and then alternatively, what we can do, maybe we can, customize our editor. So in order to be able to select, for example, which field we want to build graph on, or alternatively, we can just maybe stick to one and essentially hard code it to make it simpler. Now, because there is no actual way for me to test the API, now I suppose I could run a basic query for a basic location and say, whether API is up or not. So let's say just for the purpose of this demo, we're going to assume that it's always up. Now, if you're interested to see how, for example, we check it for Neon, you can have a look inside the Neon DB service, and you'll get an idea of how to do such a check. Now, as I said, to make it simple, we're just gonna create an observable which always returns true. Now, one of the next steps would be is to inject the HTTP client, because in order to make a request, we actually have to have an HTTP client which does that for us. So the way we do it is essentially we declare a constructor, and then we use dependency injection to inject it into our class. So now we have an instance of our HTTP client, and we can refer to it and send queries by just calling this HTTP. And there's varieties of methods like get, head, post. Now we're probably only interested in get in this case because we're not going to be deleting anything or posting data to the API. But if if that's the case, you can easily write your data provider that it actually maybe posts something before it fetches. As I said, the idea of this framework is leave it up to the developers to decide what they do and give them this flexibility. So as I said, for the purpose of this demo, we're just going to run a basic get, and we're going to have two types of queries in this case, because first we have to send and fetch the location ID. So first query would be the location query, and then second query would be to actually fetch the data. Now, in order, to reuse some of the variables and make our code more structurable, I'm going to declare a variable which holds the host name of the actual API. Okay, so now that we have our URL, we could probably move on and design our query method. Now, as you can see, the params inside the query is of type any. There's nothing stopping us to redefine it and maybe say, okay, what is the actual structure of the params? So if someone, let's say, for example, casted our data provider inside their editor, so they got the actual explicit type of our data provider, our query could have, let's say, an interface or something which defines what queries you can make to that data provider. Now, again, because this TypeScript, is only a language on top of JavaScript, so technically TypeScript is being converted to JavaScript, we can keep it as it is. And then again, to keep this video short as well, and to minimize the amount of code, for something very simple, I'm just gonna stick with any, and then I'm gonna, because I'm writing this data provider, I know exactly what's gonna be coming in. Now, as you remember, before we actually can query for, let's say, forecast, right? We have to send another query to get the WOI ID or whatever. Let's call it Earth ID just for simplicity of pronunciation. But you see, we can't really have it inside our query method. So what happens is that the query method should only be restricted for one specific query. Now, not necessarily, but if you have this, what would you call it, flexibility variation inside your query. I mean, if we search for a location and then we want to render a graph based on the return data, that doesn't make much sense. So technically, if you are designing our data provider, we actually expect, if I call a query method, I actually expect one specific type of data being returned every single time. Because yes, you can technically define a mapping provider which renders nothing, but it wouldn't make sense for a developer, let's say, who takes over your code to have such a thing. So our query method, we probably should structure it to keep it simple and to keep it consistent between the requests. We should probably structure it in a way that if you query for it, you have to supply the earth ID thing, and it always returns you the forecast. It would be nice for a user to be able to type a location, maybe select a location based on the data returned. And for that, we can define another method, maybe called query for location. You see, because the way we're gonna structure it forward, and you'll see why, we can technically, even though the data provider is being injected inside our editor as well as, to the view provider. Inside our editor, we can easily cast it back and say, okay, if I'm working with MetaWeather data provider, I can assume that it has a query for location method, which, for example, accepts a query of type string. Now, you might ask yourself, well, what's the point of having, a data provider if you have to define a separate query? But you see, you're not always going to have an API which has, a very direct and straightforward request system. So, for example, in this case, in order to fetch something, there's no way to fetch something by name, because if the search thing supported, for example, searching by earth ID and the name, we could technically have one query method. But here we are separating it into two. And if you look inside the Neon DB, in order for me to fetch, for example, the database names and everything, I can't have one query method, because this query method is only explicitly used to get the actual data. So let's say your data points or your time series or your nodes in the graph DB. Now, it's all about how you balance it out. I mean, technically what you could do is inside your editor, you don't call a mapping provider, and I'll show you later how you can achieve that. So again, it's all about how you structure, and we decided not to restrict the developers, essentially force them saying you have to use this query method, you have no other choice. Technically you could vanish away the concept of data provider if you wanted to. The data provider interface is there to keep everything structural, essentially, but there is nothing restricting you, as I said, to rewrite it in any way you wanted. And you see, the way it works is that technically inside the editor view, the query is being made, and then the data is being forwarded onto the mapping provider. So technically speaking, right, the editor, so let's say the data provider editor, knows nothing about how the conversion happens. Only those, it kind of acts like a buffer zone saying, okay, I'm the one who's making the query because I got the data from the user. And all I have to do is that once the query method returns me some data, I just pass it to a mapping provider, which in fact triggers the update on the view provider. So, so alternative way would be to structure this query is essentially have a params which maybe accepts, an action called query, or I don't know, fetch forecast or something, or you can separate it into two separate functions. Now, because I know that I'm only creating a data provider, I have only one editor essentially, and that's the editor that's going to become part of this data provider. I'll know exactly that I'm bound to my MetaWeather data provider class. So I'll know that there is a query for location. Okay, so now that we have our API in place and we have our HTTP client, we could probably actually declare the return type of our API. And in order to do that, we probably should look up here and see what actually comes back if we make a query. So as I can see, this is an array of objects essentially which have title, and it has this earth ID which we need. So I suppose just to make it simple, we can define inline data type. This is feature of a TypeScript. So as you can see, we have declared that basically whenever someone calls query for location, it will return them an object. And sorry, I actually made a mistake. It should be an array of objects. And that object, because we're only interested in the title, just to display it to the user, and then the actual earth ID, that's the only things I've decided to have there. Now you could probably declare a separate file which will contain, all the fields from here and, display every single one of them if you would like to, but, just to keep things simple, we're just going to stick with those two fields. Now, so what we have to do is essentially call our get method on our HTTP client. Okay, so here what I essentially have done, I have created HTTP GET request, and because TypeScript support generics, we essentially pass in a very similar, well, I'd say identical structure. So it's essentially what do we expect from this GET request. Now our URL is formed, it's essentially API URL and search. So as you can see here, it's API location /search/ and then query would be actual string. We create HTTP parameters for that. And query is our query, which the parameter being passed to a method. Right, so technically speaking, we could probably test this out, and you might ask yourself a question, how do we do it? Now, to make it very easy for us and easier to test, we probably should declare an editor now. Okay, so the way we declare an editor is essentially we supply additional property into our view called editor view. Now, we're gonna leave it at null just to get all the errors disappear. But what we have to do next is essentially we have to generate a component or create a component. Now I'm going to use this plugin again to generate a component, and we're going to give it a name. Now it's better to keep it consistent with the actual data provider. So essentially if you have meta weather DP in this case, I'm just going to add -editor to it. Now that our components have been generated, as you can see, it has created a very basic HTML saying that it works, a TS file and CSS. Now, before we can actually specify the class name of our editor, we have to do a few things. Now, the first thing we have to do is extend our editor, meta weather editor, from the base editor component. Now, straight away, they'll give you a warning saying that, you have to call super. And one thing I'll have to probably not say now, because I think it's very important the way it works. You see, inside the base editor component, you have a variety of different properties and everything that being assigned to it during the creation. And because the components are being created dynamically, we kind of have to simulate the change detection and, lots of other internal things. And it has helper methods for displaying an error, showing the loading indicator. It does all the unsubscription related to the editor view in ng on destroy. So the point I'm trying to make is that make sure that you call in, let's say, ng on init or any live hook cycle methods of Angular, make sure you just call super, as this will ensure that, that the parent methods are being called. So let's say in case you're doing your internal cleanup inside your editor component when you're destroying it, it's good to call the ng on destroy of a parent because it has to do its internal cleanup as well. Okay, now that we have our editor and we have extended from the editor component, we can now go and inside our data provider and, specify it here. So as you can see, we have specified our editor component. So what we've done up till now, we essentially kept the framework happy. What we have to do next is go inside our module. And as you can see in the side declarations now, that's because I used the plugin. The DP editor component was added already. One thing you have to keep in mind, and this is to do with the way Angular works, is if components are being created dynamically, and in our case they are, we have to provide a special property inside our ng module called entry components. And essentially what we do is, we specify our editor component here. So you make it one in declaration, but then inside entry components, you have to specify it as well. Now, before we can actually go and, start clicking around and start messing around with our DP editor component, we have to provide a mapping provider. Now, the reason we have to do that is because essentially the view provider and data provider wouldn't activate, the actual editor. So they are the editor views. Or in this case, I have a tab which points to a view. So they wouldn't activate unless you have a mapping provider. And the reason for that is that, in case of an editor, you only want to use the editor when the mapping provider is ready. There is, no other really use for having an editor if you can't map, your data to a view. So just to keep things simple, let's create a basic, mapping provider, and let's give it a name. We can say meta weather to, let's say in this case, let's use multi because technically we're gonna extend it to work with other view providers. So here I created a basic class, and then next thing we do is essentially we implement the mapping provider interface. And then, we use the implement interfaces from Visual Code, and it basically generates all the methods we have to implement. Okay, so now that we have our interface implemented, well, at least the method signatures are generated, I'm going to go through it and explain you what exactly each of those methods are. So as you can see, the first method is input, and if this method is being called, we have to return an observer of type any. Now, what it is essentially, the way it works, at least in this case, and in many other implementations of mapping provider, is that we create this two-way observer and observable called subject. And essentially, it's like, a two-way pipe. So if you send something one way, it will come out the other way. So that's what the input and output for. Now, input is actually used for sending the data to mapping provider, whereas the output is a mapping function. The output is essentially when the mapping function is being applied based on the input. As you can see, it accepts a type, and you see this is where the get data type come in place. So essentially, whenever a view is being given a data provider, it says, hey, my data type is this. And then and you see this is the way the observables work, is essentially you can define a mapping function, and you could have it's like a flow of data. You can look up information on the web about that. But essentially we could have multiple map functions or filter functions or whatsoever on the observable before it emits a value. So, the way it works is essentially the type is being provided. We determine based on the type what mapping function to use. And, we're going to declare the mapping function later. And then we return the final value. So what we're going to do here, essentially, let's create a basic property inside our class called subject. And just to keep things simple, so essentially I created private subject and I set the type to any. Now, once we'll figure it out what our data type is going to be, so what our data holders, we can change any to something more meaningful. Now, because subject implements the observer and observable interfaces, we can essentially return this subject. And then here we could probably say this subject as observable. Now, again, this is only to keep things very, straightforward. And as I said, at the moment, we only need this to get our editor to be displayed. Now, just like with the data providers, we have to declare somewhere a mapping provider. And, the way we do it is that the mapping is a service, something very similar, just to use the similar concept like Angular wants us to use. So we can actually create instances of that class, but this time it's not injectable. So what we do is we only need a mapping provider declaration. And just like with the data providers, we have to specify an ID. So similar structure, we use MP for this one. And let's say meta-weather to multi. We give it a name. Let's keep it simple, meta-weather to multi. And then we have to provide the last property, which is it's actually two properties, sorry. It's data provider data types. I'm gonna leave it as an array, and then view provider data types. Now, what does two arrays mean is essentially in case your mapping provider supports multiple mapping, the one which I was talking initially about many to many or one to many. This is where you declare your supported data types. And just like with the get data type and data type inside our view provider, because those functions, because those, let's say property in this case and a function or method in this case, they're being used in different scenarios, one during the startup of the app and another one during the runtime. What we do here is that we actually have, kind of like a duplicate methods called supports view type and supports data type. And what you do, you pass in your type as a parameter. Now, because our ultimate goal, at least for this one, to integrate char.js and then have meta-weather data type, what we provide here is a class name of meta-weather data holder. And then we have a char.js view provider data, already defined. And what we do here is essentially we have to check if the type is instance of one of those. Now, due to the complexity, you see TypeScript provides types, but it's still JavaScript underneath, and JavaScript doesn't really have, let's say, interfaces or any of those fancy new things. Now, with the S6, it's all coming. So what we have to do is essentially we have to check the types using a type helper, which has a method called type equals. So what we can do is essentially say this type as a variable equal to, let's say, method header. Or in this case, yes, it's actually data holder. So in this case, it's a correct way to do it. So type helpers type equals type, and because we check for supports data type, we check for the data provider data holder. I hope I didn't make it sound more confusing. So for example, for this one, the type comes in, it's same function, same exact signature, but what we check in this case is, because it's a view type, so we check if it's char.js VP data. Oh, so essentially this is pretty much it. We don't have any mapping function yet. We're gonna add it later at some stage. Okay, so the last thing we have to do, we have to go to the mapping providers module and actually declare our mapping provider in here. So now that we have it registered, and see, the only reason we do it, because technically mapping providers, they're only classes, but we still declare them as providers, but they are non-injectable. The reason we do that is in order for Angular to compile something, it has to be included into a module. It just, otherwise it wouldn't pick it up. Webpack just doesn't pick it up unless you actually use it. Now, the reason they do it obviously is to minimize, the space requirement. So, your app is not bloated with all the classes which you don't actually use. So if you go to our page, what we can see here is, let's add a char.js multiple view provider, because we have defined it, that we are supporting view provider inside our, let me have a look. So yeah, so we are saying that here that we are supporting char.js VP data, which happens to be a data holder for char.js view provider. So if we select our method header, now as you can see, because that's the only mapping provider available, it's being selected automatically. And finally, we have access to our editor. And as you can see, this is exactly the text, or the view, you could say, of our editor. If you go back and actually look inside our HTML here, you can see this is exactly what it says here. So now that we have access to our editor, we could probably start sending some queries. Now, I've done a little simple thing, is that essentially if you refresh the page, or let's say we added new functionality, the widget is there by default. You can have an examples as essentially we use a widget service to do that. And the syntax is very simple. You essentially create a widget, or sorry, call a method called add widget. You pass the dashboard ID, so it could be SC1, SC2. If it's more generic name, let's say like alert statistic whatsoever, you can set the value to whatever you think is feasible. Now, what you do is essentially you provide a name for a widget, you specify the view provider type, data provider type, and mapping provider type. So this will add a widget to your dashboard, and it's there by default because it's inside ng on init. This is inside the SC1 main component. Now, as I said, I don't really want to enforce anything. How you structure your components, how your dashboard looks, it doesn't really matter as long as you include the dashboard grid and you pass the dashboard ID. And then if you want to add a widget, you essentially use a widget service, which you inject using the dependency injection. Now, this is, as I said, very kind of straightforward Angular stuff. So, if you're having difficulty figuring it out, you probably should familiarize yourself with Angular. So I don't want to go too much into details of, how do you do the dependency injection and so on and so forth. So basically, yeah, every time we refresh the page, we can see the widget there. Everything is pre-populated. Our view provider is here. So we can, now this is, as you can see, this is actually an editor of a view provider I defined called char.js. So, I created essentially a view provider out of char.js. And as you can see here, it's being rendered. Now I'm going to go into details how to create a char.js, or sorry, view provider ourselves. It's probably going to be something simple. We'll see. But as you can see here, the most simplistic thing you could have in editor is, for example, to change the chart type, or alternatively, you could have maybe a color pickers. So for example, change each individual pie chart slice. But again, in this tutorial, we are only interested in having the data provider editor and to be able to query for the data. Okay, so now that we are here inside our DP editor, or I probably should call it a full name, method header DP editor, we can modify it. And let's say, to make it very simple, we're going to have a basic input, a basic get locations button, which is going to send a request to our API, and essentially we want to trigger the query for location method, which will return us a list of locations. So without further ado, let's do that. Okay, so I added a basic HTML with a placeholder. So if you look inside our editor, you can see, it has a basic input, search for provider, and then ideally if you click search, it should send a request and return us some data. Now, so what we do inside here is essentially, again, this is very typical Angular stuff. So what we have to do here is essentially create a variable inside our component. So let's say we could say location input of type string. And the idea is that we're going to bind this input to our, bind this variable to our input. So essentially in our editor here, we're going to use a thing called ng model. And now bear in mind, if you're, let's say you want to work with the forms, you have to make sure you import all the necessary Angular modules. So in this case, because I'm using the forms module, all the ng model binding stuff, I have to import the forms module. So once that I have a variable here, I can actually go and say we bind to ng model, and it's two-way data binding. So, if you have a default location name in here, so maybe we want to say, well, by default, I want to have Dublin, and we can get rid of the string because TypeScript is smart enough and it knows that if you're providing a value as a string, you don't need to specify the type. So if you save that, go back to our app, we see that Dublin is here being pre-populated for us. So the next thing would be to actually call our data provider. And you see, the way we do it is that our base editor component has a lot of handful methods. Now, I probably gonna go over them over here, even though they are underscore, you call them without the underscore because I create getters and setters for them. And you see what happens is because we are creating components dynamically, Angular is not aware of them and it can't have, defaults Angular input and output. So it can do the attach listeners for changes. So we kind of do it manually here. So we can define a property with underscores, which we mark it as private. And we have view provider as a property without the underscore. So we make it public. And then whenever the value is being set, we actually call ng on changes, which is Angular live hook for the changes. So if you ever wanted to listen inside your editor for, let's say, whenever data provider changes, you could, intercept them and maybe, do some cleanup or whatever is needed. Now, keep in mind that you don't actually have to access this class. As I said, because you're extending from it, you're just given this, handful methods, which you can start using inside your editor. So what we can do here is essentially inside our ng on init, now that we have called super, we could probably refer, just to keep things simple, we could refer our meta weather data provider. So for that, I'm going to create a variable called mwdp. And inside our ng on init, we gonna say this data provider. And you see, because the data provider implements, it's of type data provider, we just have to do a casting, just like we do in Java, for example. So you see here, we know that because we can always be sure that in case of an editor, and because we created this editor explicitly for our data provider, we can always be sure that our data provider in this case would be meta weather data provider. Okay, now that we have a reference to our data provider, we can create a function maybe called search for location. And what this function will do is essentially call a function on our data provider called query for location. And as an input, you remember, we have our location input, so we pass it as a parameter. Now, because it's a observable, we have to subscribe to it. So what we do is essentially we subscribe, and we can just call data for simplicity. And let's just console log it and see, in the console if it actually returns us anything. But before we do that, we obviously have to call it inside our HTML. So we say on click, we call search for location function. Save that and go back to our browser. Now, one thing I like to point out is because you see the API was designed to be consumed by the web servers. What happens is that I had to disable the same origin policy just for the purpose of the demo. Now, ideally, what would happen is that, if you're targeting your own API, so let's say your Neon server or something, you should add explicitly your CORS rules. So, the cross-domain origin thing. But, just to get things working, I essentially have my input, search, and if we click that, we should see in the console, we're being returned Dublin, the location type city, and we have our Earth ID. So now that we have our location in there, and we have our ID, we could potentially maybe display a list of, all the potential matches, or alternatively, we could, for example, just select the first one, for example, first match, and then send the request. So I try typing SA, for example, here, and as you can see, it returns you a lot more results. So I'd say, you know what, let's actually have a proper select box so you can select an individual record if you wanted to. So the way we would do that is essentially we have to define another set of UI for it. So maybe let's create a basic select box. And what we have to do here is, you see, ideally we would have to store what was returned by the last location search. So now that we have our data and we know the format of the data, we could probably store in one of the variables in here. Now, as you can see, I have defined a variable called last locations, and I have declared a type and earth ID. And you see, that's why it's important probably to declare it in a separate file. So as you develop in it, you kind of make it easier for the developers to refer it. Because you see, every time I have to open this, use this notation to define my data type. Whereas in fact, if I, let's say, declared a separate class and called it, I don't know, location search result, I could probably reuse it here. You know, that's two places, and then third places would be inside my editor. So it's better if you create in your own types, create them as interfaces, and essentially try to reuse them between your data provider and your editor. So now that I have my variable declared there, I can actually just say last locations equal to data. So now our locations are being saved in the variable, and what we can do inside our thing is to use the directive of Angular called ng4, and what we would do is essentially loop over our last locations and then display them in a select box. Okay, so as you can see here, we're iterating over the location, and then our value would be our earth ID, and then we use title inside our option. So if we go to our dashboard, and if you go inside our editor, what we can see here is, I mean, let's search for something that we have multiple resources. For example, loan would give us Barcelona, London, probably. You can see it's being populated here. So we're actually fetching, you know, the real data from our API. Now, the next step would be to probably add another button called send the query. So essentially, you know, it's kind of a two-step process. You select you search for location, then you select your location very specifically. So, you know, if I type Dublin, that's the only option and it's automatically selected for me. So what we could have is essentially, you know, find the Dublin and then straight away click send query. Now, before we do that, we probably have to know what location was selected. So we create another field called selected location. And then again, as you can see, that's where our type declaration would be useful if we declared it a separate file, but we have to copy it. That's fine, just for the demo. Actually, you know what? Let's create a separate file. Just make it easier. So inside our my DP, I'm just gonna create a location info, and essentially I'm just gonna copy this. So now technically we could replace all of those declarations by just met weather location info, and let's do the same inside our data provider. So let's just verify if everything works. If you go back, search for Dublin, Dublin is there. Everything's perfect. So now that we have additional variable called selected location, what we have to do is again use ng model to bind to it. Now again, I won't be going into details, you know, how ng model works and, you know, the two-way data binding. You can look it up on the web yourself. So let's add another button essentially to query for the actual forecast. Now, as you can see, we have a button here now. So I've added a button. Here is our essentially a view for it. And as you can see, this is empty. Now, what we could do, and we probably should do, is that if there is no locations in the list, so technically there is no location selected, we should probably prevent this button from being cleared, because technically we can't make a valid API request before we actually have a location provided by the user. So essentially selected from this select box. So what we'll have to do is essentially say selected location, and we can use the property binding of Angular and say, okay, it's disabled if selection location is, for example, undefined. So we just use the, you know, the standard way of declaring false values, so null or undefined. So if we go back to our view, we can see that the get forecast is disabled until we actually search and select a location. Now, one thing we probably have to do is to clear out the selected location every time we search for something. So if we go back to our editor and say select location is equal to null, and this way we'll ensure that if, for example, we go in, now again, all of those specific things of how you program everything, you know, it's up to you to define if you want this validation check-in or you don't. But it's just better to keep it, you know, safe for yourself. Now, as I said, it depends how you structure your data provider. Maybe your data provider is okay if you accept, if you supply no ID or something, you know, it has to be treated on a case-to-case basis. So as you can see here, it clears it out until we actually select the location, so everything works fine. Okay, now that we actually have our forecast, or sorry, now that we have our location, we can actually fetch our forecast. And as you remember, the way we designed everything is that our query will do that. So what we have to do here is essentially design it in a way that it sends a HTTP GET request and then fetches the information for a provided location. Now I have a param set as any, and this basically means that could be an object or an array or anything. But you know, just to keep it simple, let's say that our params is essentially this earth ID. So what we have to do is make another HTTP call. And if we look inside our API, we see that it's essentially location, and then we pass this earth ID as a parameter. So instead of having search in here, now I copy pasted the thing, we're just gonna say params. Now, one thing to do is probably to define what exact response type of this HTTP GET is. So what we're gonna do is declare another interface, which will be, you know, the return type of this. So let's say we could have a title. Now this is name of the location, obviously, but we don't need it. But I'd say the only thing we needed is the consolidated weather, and then we might need the temperature, for example. So I'd say we just go with that temperature, which I assume is kind of like the mean, an average of between mean and max. So let's create another file inside our data provider folder, and maybe we should call it forecast info. So looking at our JSON formatter, we know that each weather item is an array, and each of them represents a certain date. And as you can see, the forecast is given for 5 days ahead. So because the only variables we're interested are the temp, which is a float, or in this case of a JavaScript, it's a number. And another property we're interested in is the date. So for example, we can group by that date, and you know how, let's say, our bar chart or line chart group by that date. So you can say, you know, this is our basic forecast response type. So you see, because we already know what type of, let's say, query in this case, we know exactly what we're returning. You can easily override those values, because let's say in data provider I use any, but you know, there's nothing stopping you specifying the exact type. And in fairness, we could say that the params is actually, if I hope I spelled it correctly, like that, because the params could be any. And then again, you could, you know, come back and change that. Now, ideally, you probably should have it in an object, and, you know, the likelihood is that more than likely you're going to have more parameters being passed into your query. But, you know, just to keep it simple, let's have it just a number, just the earth ID. Okay, so now that we have our query, we showed that it probably should test it. So if we go back to our editor, right, and maybe we could create a method called getForecast, which in fact will call our data provider and explicitly the query method, which accepts the WUI ID or earth ID, as we agreed to call it. So now that we have our selected location, we could just say, okay, this selected location, and we can get their WUI ID. Now, this is where we have to essentially have a next step to a mapping provider, because ideally, you know, I suppose for testing purposes, okay, let's output our data into the console. And there's one little thing you'll notice, even though we only defined few fields inside our query, or sorry, inside our model, saying consolidated weather and the temp applicable date, they are only used as typing, so essentially for auto-completion purposes. And what will be, you know, the data actually returned underneath, because it's plain JavaScript, it's still gonna contain all the fields. So we're not limiting the fields we return, but we rather declare the expected fields. So just so you keep in mind, just because you defined 2 fields here, you're still gonna receive everything. So now that we have this get forecast, we could go back to our HTML and then say, when this button is clicked, we call our forecast function. Now there is one modification we have to make is, as you can see here, I was binding to location the earth ID, but we actually probably should bind to an entire object. Now, it's up to you, but you know, if we have this functionality, why not to bind to entire object? So if you select something out of a select, even though you see the title, technically you still have access to entire object. Okay, so now let's test what we have done. So we have Dublin, we click search, and then we select Dublin from the list. And if we click get forecast, we should receive the data. And as you can see, we still receive, as I said, all the sources, all the, the title, so the actual location and stuff. And what we're essentially interested in is inside the consolidated weather array, which contains the temp. So what we can do now is finally move in to create our mapper, right? Because we can query for location, we figured out how we access our API, we figure out, our query function, how we get data. Now it's a matter of sending it to our view provider. But before we do that, we have to actually call our mapping provider. So as you remember, there are actually multiple properties available to us through the base editor component, and one of them is mapping provider. And essentially what you do in here is you call the input, and because it returns you an observer, you call next on it. So next is essentially saying passing data into this pipe, and it will come out to whoever is subscribed to it. Now, as you remember, our mapping provider had any. So if we actually look inside our mapping provider, which we have defined previously, is that our input is of type any. Now, you could probably do a casting here, but it's not necessary. I mean, it's still, the correct mapping provider will still be called. Let's keep it simple. See, now that we passed the data into the mapping provider, if you went straight away and let's say, for example, just gonna resize it back. If you try to go and let's say search for a location, select Dublin and call a method, you see it already gives us an error because our view provider expects the data to be in certain format. But if we go back to our mapping provider, we'll see that we're essentially not doing anything. We just basically say, okay, whatever comes in, comes out straight away. So we don't do actual conversion. And this is where we define our conversion functions inside our mapping provider. So what we do is that because we know the structure of chart.js VP data, so it accepts a set of label and then our data sets. If you keep following, the data structure of it. So for example, this comes directly from the chart.js, and we can see this is all the parameters you can pass in. So, you could have your data, which is essentially a set of numbers. So what we could do in this case is that our labels would be, let's say, our dates, and then our numbers would be our the temp values. But before we do that, again, as you can see, the output has a type function. And the way it works is that inside the view provider, you subscribe to output, and then you pass in your type. And that's where the get data type is being used. So essentially you're saying, I'm this view provider, I support this data type. Can you make sure that if whatever comes in out of your pipe before it gets processed to me, this is my data type, please convert it. So this please converted functionality will be implemented in here inside our output. So the way we do it is essentially in here in our output. And because again, the observables are streams, we can have a mapping function and then mapping function. So let's say in this case for a mapping provider, I'm pretty sure that the data coming in, and because I'm working with this data provider, I know that the data coming in will be of type meta weather data holder. And the type could be T. So based on what was passed in as a parameter, this is essentially what we're going to return, just to keep it consistent. So again, we see here that we pass in the data and we know that the data is type of meta weather data holder. And what we do next is essentially we use this type checking. So we use type helpers, and this, we check if type equals and our type. Now bear in mind, this is the view type. So we have to check against chart.js VP data. So let's say if we know that, okay, this is actually, the guy who's listening is listening for chart.js VP data, and sorry, by guy, I mean view provider. We can, for example, say this, and we're going to have to chart.js map function, whatever, let's say to chart.js, and we're going to pass in our data. Now, there's one thing that it's probably going to complain about is that it doesn't exist. Well, obviously we have to create it and then say that our data is of type meta weather data holder. And you see, it will still complain, for example, here in this case, saying that void is not assignable. Now, this is because we don't actually return anything here. So we can say that, okay, this actually returns char.js VP data. And let's say just so to keep the compiler happy, we say it's null for now. And again, you see, it still will say that the type char.js is not assignable to type D. So you have to do this very simple casting to any. Now, this is, again, a workaround to keep the compiler happy because you see, this is a generic, so it doesn't know at the runtime what type it's going to be. And you see, the type helpers doesn't actually help it to determine it, unfortunately, just the way it works. So you have to cast it to any. Now, you're probably going to get used to this, way of writing the code because it's actually similar across all the mapping providers. The only thing which is different is essentially your actual implementations of the functions. Okay, because we know exactly what format the data comes in, what we could do is, build an array of labels and then pass them to the char.js VP data. So I'm just going to create a char.js holder, which is going to hold our data, and I'm going to assign labels to it. Now, the labels are coming from our metadata thing. Okay, guys, I have to make actually a small correction. As you remember, we created a meta weather data holder. So technically the forecast info is not needed anymore because we have our data holder. You see, you have to define a class because interfaces don't exist in JavaScript. They exist in TypeScript, but in TypeScript, there is not such a thing as interface, at least for now, but there are classes. So if you want to do the type check, and you essentially have to work with classes. So we can probably safely delete that if we haven't actually used it. Let me double check. So the only place we have used it is inside our data provider. So we just return a data holder. Now you could call it, we could change either or, just, I made a mistake that I forget to reference a data holder and I created a separate interface for that. But it's a simple fix. And, as you make more and more of them, data providers and view providers, you'll get up to speed. Okay, so now that we have our data holder in place, we can actually call fields on it. So because we have consolidated weather, we could run a map on it and let's say extract all the applicable dates. And this is going to be our labels. Okay, now essentially this is our labels, and I suppose we can test it out as it is. So technically it should render at least the labels. So if you go to our view, and as you can see, the data came back, we have our labels. We don't have our values yet. That's because we haven't mapped it. But this is already a progress. I mean, we have a data provider, we have a mapping provider. So, it converts one JSON object into the other, into the format. And you see, you can extend that mapping provider to work, let's say, with a table view or with anything else. And you see, the beauty of this solution is that you don't have to touch the editor code, or you don't have to touch the data provider code. It works as it is. The only thing you'll have to do is essentially change your view provider. So add another widget, and then change your, mapping provider. So if you go back here, let's finish up. And essentially what we have to do now is create the data sets. Now, we're probably going to have only one data set because technically, we're not fetching multiple locations, even though you could, let's say, compare Dublin weather to London weather. But in this case, we only have one data set. So as you can see, I'm just creating one data set and I'm going to pass the data. And to make things simple, again, I'm going to use the map function and I'm just going to extract, in this case, the temp. So if you go back here and try to query for the data, we can see the values of the temperature. So here you go. It's essentially a very basic example of data provider. We implemented mapping provider. And as you can see, the reason that whole load of code, and I know you might be thrown out by the fact that, you have to define your output, all this mapping, if statements. But if you look for Neon, for example, it's the same idea. It's map, you have Neon data holder, Neon to char.js, Neon to basic table. It's pretty much the same. The only thing which is different is the actual mapping functions. Because, for example, inside the Neon, I'm checking, I'm checking what was the original query, because let's say for aggregation query, I can definitely show the data for char.js. But, if you run a basic query, let's say, fetch all the rows, I can't really render it as a table because there is no X and Y concept in that. So, I just basically return an empty char.js just as a fallback. We technically have it. And I mean, let's say in case of char.js, as you can see, we can easily change the type of the charts, it's kind of built in inside the view provider. So I'd say the next step would be to implement our own view provider, because this is something we actually haven't looked at. And to keep things simple, we probably wouldn't have any fancy stuff for, let's say, the actual editor, because what I was thinking for this tutorial is to have a basic widget that, let's say, displays something similar like they have it with clouds. So for example, we could have, if it's snowing, maybe show a temperature underneath, I don't know, a wind speed, just keep it simple, right? But there you go, guys. I mean, if you wanted, for example, to implement, a thing for a table view provider, all we have to do is essentially redefine our mapping function. And let's say the data holder for a basic table view, just let me have a look where it is. You see it accepts headers and it accepts items, and that's it. So headers, let's say, would be your keys. So you could say the data returned from here. You can display it in form of tables, say ID, weather, state name, weather, blah, 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 whatever you need. You could define your own fields, or limit it to your own fields. So yeah, so now that we were able to do that, I'd say let's create a view provider, very basic one. And then I'm gonna, once we have the view provider as well, I can talk about having, the configuration, the global configuration, and other kind of little nice features of the framework. So, just so you know how we can improve it, how we can, for example, show an error message or display a loading indicator when we fetch something over HTTP, just in case there is a slow internet, the user is aware that something is being fetched. Okay, guys, so let's create a view provider and create a separate module. So if you're defining a view provider, just like with the data provider, create a separate module just in case you need to have, nested components in your editor or whatsoever. Just keep it all under one. So I don't know, let's create a nice weather widget. So we're going to give it a name called weather VP. And as you can see, it has generated as a module and has generated as a component and HTML. Now don't forget that because I'm using this plugin which generates everything for me, it generates things I don't actually need. But if you look up, this is essentially a plain declaration of a file, of a module, ng module, right? In this case. So, you include your ng module, you always have to include common module, and then you have your declarations for components, and obviously you're going to have entry components. So in this case, you see the view provider is also an entry component, whereas with data provider, we only supply the editor as an entry component. Saying that, we won't actually have an editor for this one, even though the structure is exactly the same. You create your component, and then in your view provider declaration, just like in your data provider declaration, you can supply an editor view. And if you did supply it, it will be rendered, otherwise it's going to be disabled. So I'm going to use this tool which helps me to generate stuff. So I'm going to create a weather DP component, and it will generate all the necessary files like HTML and CSS for me. Now, to keep things simple, what we could do for this one is maybe create a basic, an image of a cloud, and then maybe show more information. So have, the temperature, minimum, maximum, maybe show the wind speed, make it a nice informative widget of, let's say, weather for today. Now, one thing you're probably going to see straight away is that, we fetch a forecast for 5 days, but you see a very simplistic way to go, around this problem is essentially to have a mapping function which will work without weather VP component. I should probably rename it to VP. Okay, now that I have renamed it to VP instead of DP. So, our mapping function, essentially what it's going to do for our view provider is it's going to just extract one date and pass in, I don't know, maybe as an example, we could say that our view provider data holder will expect you to supply an image URL as well as temperature, or let's say minimum, maximum, and average temperature. And we could say another one would be wind speed. And then what we'll do inside our function is, map it to our, from the data provider of our, from the data holder or data type of our data provider to the view provider data type. Now, because we have declared a module, we have to again go up the chain, and then we have to import that module inside our view providers module. So what we can do here is essentially say weather VP module, imported it, and as you can see, Angular rebuilds, and now it is aware that we have declared such a component. Now, if we go inside the component, just like with the editor, the component has to be, well, as you can see, it's declared, but then you have to create a view provider declaration for it. And then you have to make sure that you're extending from base view provider. Now it'll prompt you essentially to implement certain methods. And the reason for that is, I have no idea of what your view provider, and by saying I mean, I'm talking about framework. So framework has no idea of, for example, what your data type is. And then let's say when the data arrives, it just notifies you when the data arrives. And then clearing view, it has no idea how you can clear the view. And I give you an example. So for example, clearing the view is being triggered whenever you switch a data provider or you switch a mapping provider. So, instead of having the old data being displayed, you have to define the steps essentially how your view provider will be cleared. So in our case, we could maybe display a message saying no data or something. And just like with the other one, we have to call super. And again, if you have ng on init, we have to make sure we call appropriate method. Now, in this case, as you can see, I don't have anything on init, but just in case I do, and as you can see, the autocompletion tells you if you do anything or not. So in this case, we don't, so we can actually leave it out. Okay, so just like with the data provider or mapping provider, we have to have a declaration file. And this time it's just called view provider declaration. And again, you have to pass in your ID, your name, and you have other options which you might or might not pass. So to keep the name the same, let's call it VP, and let's say call it weather. And in this case, again, we have to create our data type, which we're gonna do now. So let's call it weather data holder. And then again, it has to be a class. And then what we do is say that we're gonna have an image URL of type string, and then we could have a minimum temperature, which would be a number, max, maybe give it actually a name temp, so people know exactly what it is. And maybe we can say wind speed. And we could probably define an empty constructor now, because all of them are public anyway. That's not an issue. And don't forget, we're only using as a data holder. We don't have any complicated logic inside our getters and setters. So we could, use it directly. So here as a type, we specify our weather data holder. And ideally, we should implement, obviously, all of those methods. Now, don't forget, you have to return a data type in here as well. So we have to make sure we call it here as well. And we might, instead of any, declare the actual type. Now, on data is essentially when your data arrives. So again, the type wouldn't be on any, but it'd be rather your data holder. And your clear view would then, be a function which we're going to develop later. So if we look inside our HTML thing here, we can see it's just whether VP component works, which is, enough for now. So before we can, proceed and actually start adding stuff, we actually have to go back inside our module here and define an entry components. Because remember, because this is being created dynamically, Angular has to know what it is and, kind of pre-build the skeleton of the component in case it's being created dynamic. So once we have done that, we can see that our weather widget is actually available now. So we can add it. And as you can see, it renders the HTML inside it. Now, if you go inside this one, we can try to select the weather, but as you can, the data provider, but as you can see, it doesn't work because we haven't defined our mapping provider to work with it. So what we have to do now is essentially, first of all, we probably have to define our how our view is going to look like. And then alternatively, as in next step, we should probably define our mapping provider function. So to keep things simple, let's maybe create our structure, how our thing's going to look. And what we can do here is essentially create maybe a basic, like a box, and specify the width and height be 100%, add margin, or actually padding from each side. You know what, guys, I actually changed my mind. I decided to actually show everything. And for that, I'm probably going to use like a list. I don't know if you've seen the list group from Bootstrap. So then we could probably have, change our holder to actually contain entries and make them an array to make things easier. So here what we can do is essentially use the same thing called ng4. And if you go back to our component, we probably have to create, whatever comes back from the holder, we probably should store it. So I don't know, an example would be, we could either store the entries directly or we can store entire holders. So let's store entire holders for simplicity. Just gonna copy paste that. And in here, I could probably say this data equal to data. Now, because our data could be undefined or, not there at the moment of creation of the component, we'll check if the data is there. And if it is, we can then attempt to code, let's say, on entry. Now in our list group item, show the minimum temperature and then show the maximum and maybe add a text. Now looking at this, at the moment, I can probably say that we have to define our custom CSS, to position the image relatively to the li class. And maybe actually that'd be good example and exercise of how to do it. Now, as you remember, our minimum, maximum temperature and wind speed they are part of the response, but we never actually declare them inside our data provider. So I don't know, maybe let's do that now. So, just so we know that it's there whenever we're going to be typing it. So as you can see here, what I've done is essentially added additional parameters, minimum, maximum temperature, and the wind speed inside our meta weather data holder, which is used by data provider. Okay, now that we have our data provider, the best way to do it would be to actually test how it works. It would be to actually, what we have to do is go and define, extend our mapping provider. So we have to go back to our mapping provider, which we call meta weather to multi. And one of the things we have to do here is essentially say that it accepts meta weather data holder conversion to char.js VP and now to a weather data holder. As you can see, the class names, how you define them, again, is probably going to be decided by the actual Horizon 2020 crew. I mean, you can either go with char.js VP data or data holder or, whatever sticks best. So what you have to do here is essentially extend our function and another if statement saying, well, now we support the weather data. So you have to check if type is weather data. Then we have another function to call to weather data. And this function will be something similar like we have to char.js. So it will accept this meta weather data holder, but it will actually return weather data holder. Now, what I probably should do is essentially rename it to VP because, people might confuse it with our existing data holder for data provider. So we call it to weather data. And what we do here is essentially we create our weather holder. And then we return it. Now, as I said, we should rename it. So let's run into weather VP data holder. And we're going to save it across the entire project. So what we do then is our entries. Now, don't forget our entries is essentially an array of wind speed, minimum temperature, maximum temperature, and the image URL. Now, as you have seen is in the API, the way we form the image URL is essentially we say static image weather, and then X is the abbreviation which comes from the weather state abbreviation. So I'd say this is another property we have to add to our meta weather data holder. So just so we can get auto completion for it. And then we're going to use the images provided by meta weather API. So what we have to do here is probably, maybe this is not the best way to do it. And then again, because, this is more for the demo purposes, we can hard code the URL in here. So essentially, how would we form the image URL? Technically, it should be returned by our API, but our API doesn't do that. So what we do is essentially in our map function in here, which we're going to use now, we're going to say, okay, data consolidated weather map. So we're going to return a new object, and that object, essentially what it has to be is match our format, which we have defined for our data model, VP data model, data holder essentially. So we can copy that, and then we can copy the URL again. So let's say our URL will be formed just by taking the abbreviation, and this is how we forward our image URL, and then we can say v minimum temperature, v maximum temperature. Now I suppose you're familiar yourself with the map function, so it essentially takes an array and then maps it out to another array essentially, and that's what we'll be doing here. So our entries are there now, and we have declared that it supports. Now, another thing we have to mention, the way we had it here, so the view provider data types inside our declaration, we also have to add it here. Now, the way we do it is a simple OR statement. So, you can form them in this format, and then we just specify, another view provider data holder type. So now that we have added that, we have added another function. All we have to do now is add our widget, go inside it, select our meta weather, and as you can see, meta weather tumult is being selected. And that's the thing about it, is essentially we're using the same mapping provider, same data provider, but the views are different. So we can render temperatures in here. But then if you go here and let's say we select for Dublin again and Dublin again, now the request is happening, and I'm going to show you how to show the loading indicator, how to handle errors later. But as you can see here, the data came back. So what we have here is essentially kind of a minimalistic example of a view provider. Now, we don't have our images yet, and we probably just forget to include them. So if we go back to our weather thing, and you know what, let's actually directly try to insert an image tag and see what happens. So for example, here I have inserted the image tag and passed in the image URL. Now, another thing we can do is probably change it to a decimal place of 1, because I mean, it's big as it is. The number seems to be very large coming in from the API. So let's maybe make it fixed to 1 and see how it renders. So if you go to weather widget, add it again, go to edit, select our meta weather, then search for Dublin, select Dublin, and here we go. Here we have the data. So you can see it shows you a very, nice little icon. And then if you go here, it scales appropriately, and we could resize it. So we have our widget defined. Essentially, we have defined our view provider. And as you can see, what we render inside is completely up to us. So this probably covers the basics of it. And then, I mean, if you want to search for London, right? So let's say you want to get forecast for London, it's as easy as that. The view provider updates, you don't have to touch it. Once you define your mapping, it's there. So, this pretty much covers how to define a view provider, how to define a data provider, all the basics. Now, I'm going to go into details because, for example, let's say we search something here and we got a forecast, everything works fine, and then we do the basic save and restore. You see, what happens is that we don't actually save the user selection. So technically all of that is being lost. So the minute, you leave the page, for example, and we have no information of what was the user selection. So in this case, we might need to store information. Oh, did the user enter a username or password? Or maybe he specified what exact query he wants to run. And you see, this is where the configs come into place. So configs is essentially like a state of the widget. There's two types of configs. One is config. One of the configs is actually related to the editor. So it's kind of an editor config. So each individual editor view, so let's say view provider editor and data provider editor of this widget, they have their own. And so does this one. Then there is also a view provider and data provider global configs. So for example, if you have a data provider and you want to authorize user, let's say globally across all the widgets, so they don't have to re-enter information, there is this, you actually can see it here. It's being serialized here. So you can see view the provider, and because it's just an empty object, we don't actually store anything. It's empty. And same applies for the editor config. And then as well as that, I have configurations for every single data provider and every single view provider. So you can see our weather one is here. So this is our kind of like a global configs I was talking about. So the next step of this tutorial would be to actually create, well, not to create, but to actually use the configurations, so use the editor config. So if we serialize and let's say save the dashboard as a JSON somewhere in the database or local storage, and then if the user comes back, we can actually restore it, to original state and have the queries, for example, and have the query, populate the widget automatically. Now, there is one thing we actually missed out is the clear view method, and I can show you exactly what is wrong with this. Well, what is wrong for not implementing it. So let's say if we searched for location, selected it, and got the forecast, and then we decided to go for a heat map. As you can see, there is no data provider. So technically we changed a data provider, but because there's no mapping provider, we're still showing the old view. So the way, let's say we would do it here in this example, we would probably either clear the view, so hide it completely, or internally what we could do is set our data back to null. This will essentially hide the list because as you can see, we have ng-if data. And if we try to, for example, do the same thing again, so if we select data provider, search for Dublin, and then if we switched it here, as you can see, it clears itself out. So the next thing I'd like to talk about would be having the indicators, having the error message. How would you handle an error message, for example? So, or there is actually another concept called warning messages. So for example, if there is no information being returned, or let's say there is no location available, we could probably potentially show an error message or warning message. Like the most common use for the error messages would be either API replies or, for example, error API replies, or if, you failed to connect to some service. So one of the first improvements we can do is we can add loading indicators to our editor. So if we go inside our editor and whenever we make a query, for example, what we can do is essentially say this. And again, those handy methods come from the base editor component. And we can say show loading indicator. Now, the way it works is essentially you're showing, but then you have to hide it. So let's say once you have received your data, you call hide loading indicator. And this applies, for example, for the forecast as well. So we call this show loading indicator, and we say this hide loading indicator. So let's see how that works. So if we search for Dublin, select one, as you can see, it shows us a little loading indicator, which indicates that something is loading. Very simple. Now, let's say if an error has occurred during our loading time. You see, the way it works, that subscribe actually accepts multiple callbacks, and one of them callbacks is called error callback. And what we can do here is say, and the function we call to display an error message is display error message. So maybe we can get an error and, I don't know, try to get a string out of it, just to, do the proper casting essentially. And we could probably replicate it, for the other one as well, because if there is any HTTP error, API error. Now, depending on the structure though, you might change that. So let's say if the error occurs and this is not a standard HTTP error, so it's not like, a connection is being failed because you are disconnected from internet, or I don't know, the server is down or something. If it's a proper API reply saying you forgot, to pass some parameter or something, you can do additional parsing here and you can actually determine what you display. Just for the purpose of this demo, I'm kind of stick with the simple string error. And if you want to see more advanced way of parsing, for example, Neon errors, you can have a look inside your the Neon service and then Neon editor. Now, bear in mind that we only hide in loading the indicator when the success happens. So what we have to do is we make sure that we actually hide it on error as well. Now, the way we're going to test it is essentially we're going to trigger this cross-origin error. Now, my Chrome is set up to run without any security things. So basically disable security. But what we're going to here is open Firefox and let's say try to fetch the data. So do a basic search. Now, one thing I had to change is I was getting object because apparently the string call wasn't actually calling toString, or maybe the error object of HTTP client of Angular itself doesn't have toString method. So now you should never do that in the actual real thing, but I mean, just because I know what type of error is gonna come back for me, I'm just calling error.message. But in the reality, you should probably write your functions more carefully. Here, what happens is that the error here is HTTP failure response for unknown URL 0, unknown error. Now, this happens because due to the cross-origin request policy, so it's being blocked. And then my Chrome, the only reason it works in Chrome because I have disabled the security implicitly just for the purpose of this demo. So as you can see, very simple concept. So you can display error message, and then, in case there is an error on a widget, you'll know straight away that, hey, there's actually something wrong with this guy. So, if you have multiple widgets, you'll be able to easily identify that there is an error. And then if you click into it in the general tab, you can see that there is, a more descriptive full stack essentially of an error available. Because you see this one trims to 300 characters, and this is done, so if you hover over, you don't end up having a large big box of, in case of a Neon, it's a huge Java stack of all the functions. So, this is a basic example of how you can have error message or error handling in your system. Now, as I said, make sure that you know exactly what type of error comes back. So maybe check if it has message. Ideally, it should have if they use, if the library you're using, they're using native JavaScript errors. But in case of a Neon, they had their own wrapper around Ajax, and, let's say they had a response text, but that response text could have just a generic error. So if you're interested how I got it done, you can have a look into the editor, and it's pretty self-explanatory, and I'm sure you can figure it out. So now that we know how to handle our, little indicators, error messages, and so on and so forth, let's have a look into the configs. Now, as you can see, we have our location input, last locations, and selected locations defined in here. What we could do technically, okay, is only save the selected location. So what we have to do, we have to change our code a little bit. So what happens is that the config is always available by default. And if you want to listen to editor config changes, there is a method for that. And our changes would be of type config changes. And essentially, they'll be very similar to how ng-on changes works with their simple changes, that each change has a property of a config that was modified. Now, your config could be anything, essentially any object. It's just plain JSON. So, for example, what we could do is we could have selected location as our change. So we can say, okay, selected location change equal to changes selected location. And what we can do is essentially say, if selected location change is defined, and let's say if it has current value, then we might display and render it. Now, this approach is good, but what might happen is that if you want to reset it to null, for example, you wanted to reset it to null in config. So let's say with the ng-on changes, you would actually check if current value was defined, but in this case, we do want to allow, do want to allow null values in this case. So bear in mind, the change has current value and the old value, and then it has the first change. Now, what the first change could be used for is that you have to keep in mind that the editor config changes fires up straight away. So it fires up even before your view is loaded, because your config changes might actually have the variables that you need in order for view to be initialized. So what you can do here is essentially check if it's a first change. You could do nothing, or essentially say, well, if first change is equal to false, then you could probably re-render your UI. So in this case, for example, what we could do is have another method saying location changed, and maybe, let's declare it somewhere upstairs. And you see this location change would actually go back into our HTML. So as you can see, we have ng model, and you see we've defined a two-way data binding saying if something was selected, we actually want to trigger ng model event, and this triggers ng model change, and it basically ng model change binds to selected location and it updates it. What we have to do is modify that. So essentially we say that we only care about reading selected location, but then any changes to ng model, we want to be propagated down to our new location change function. And then in our event, in this case, it would be actual value, or maybe we could call it new location. So we might as well, for the time being, just console log it and see what it prints out. So if we go back to our app or to our website, try to search and then try to change a location, you see it prints out the title, the earth ID, and so on and so forth. Now, if you remember, I was using the ng value and saying it's good to bind to an object. And actually, here is the reason why, because, you can have an entire object in there. Now, if you're going back to the editor, what we can do here is essentially update our config. And the way we would do that is go in this, call editor config. As you can see, you have access to data provider config and view provider config. But in this case, we are only interested in the editor config. And we call an update. So our update method can take any JSON. And then if you want to be very specific, and let's say you define your config is the interface, you can actually pass what properties to expect. So this is more a convenient method, just so you don't have to copy paste or trying to remember what your properties are in the config. I assume you're going to have some sort of a model inside it and be easier for people. So maybe, other people who wants to update your configs. So for example, we could create maybe a separate file called MetaWeather DP editor config or something. But, just for the purpose of this demo, I'm going to leave it as plain object and have selected location, or maybe let's call it saved location. And we're going to actually set it to a new location. Now, one thing to have to bear in mind, because we call this a saved location, we have to make sure that our changes we actually acquired is called save location as well. So we're going to rename all of them variables to saved location change. So what we're going to do here is essentially set our selected location to saved location change, and then we're going to get the current value. So this way we're essentially updating it. Now, because we're not updating any UI, we could probably set it directly, just like that, because we don't need to listen for force change. But if you have, let's say if you, for example, with the Neon, I had the database name, and then database name was stored in the config, and then I had table names. But you see, whenever you change the database name, you have to update your table names accordingly. And before you can do that, you have to make sure the view is initialized. And that's why if we actually look inside my editor for Neon, you can see that what I do inside my on editor config, just let me find it. Actually, it's here. So you see what I do is I make sure that it's on the first change and that there is actually a current value. And only then I update my table names, which in fact, shows loading indicator and clears error message and then hides it. Those are all the usual stuff. So in this case, we're not doing it because technically we don't have any other UI which is dependent on the selected location. Now, one thing we have to keep in mind, obviously, is inside our, and this is again very specific to how Angular works. You see, the way we use the object, we have to provide a method which compares currently selected value, because that value comes as a separate object. You see, the reference for that object is different, and it doesn't actually get selected. So what we're going to do for that is use compare with and pass in our custom function, which we can actually define inside our MetaWeather editor thing. So as you can see, I define a basic function which says, okay, if A or B is undefined, then they are not equal. And otherwise, if they are defined, I'm just comparing their earth ID and they match. Perfect. And it essentially works. And the one exception is that it has to be defined on the select level, not at the option level. But then again, this is, if you're familiar with Angular, you should know that already. So if you go into our data provider and click search, select Dublin, get forecast, and you see that everything loads successfully. Now, what is different now though, is that if you go and actually select a location, get a forecast for it, and let's say we exit out and try to do save and restore, watch this. The saved location is now stored in our data provider editor config, and we actually store everything for it. Now, our thing, when it restores, it still, doesn't re-render the graph, and that's because we never actually ask it to do. Now, the way we're going to do it is essentially inside our ng on init. So whenever the graph is initialized, what we can do is check, okay, is selected location available? And if it is, well, then get us the forecast. So now if you go back here, and let's say the very first time we try to do it, it wouldn't work because as you can see, we don't have a location in there. But if we go search for one, select one, get the forecast, we don't even have to get the forecast, if to be honest. And then call save restore. It should technically run our query again. And as you can see, it does. So now we can actually, be sure that our widgets are restorable. And if the user enters and specify the location, they always get it back. Now, the only drawback, as you can see here, is that it's not being populated here because we have this two-way step process that what happens is we basically take, we search first and then it populates and then we select, then we get the forecast. Now, one thing you probably noticed is that this button is disabled, and the reason for that is because of the way we update the stuff. You see, what has changed is that we can't really say selected to null here as we used to do it. What we have to do is any modification to any of the properties have to be done through this update method. So technically, whenever we reset something, Let's say we got a forecast and then we searched again. We have to make sure that, we reset it in the config as well. So if someone tried to run save restore, it actually got cleared out. So now, one thing we haven't done is essentially, as I said, is that the location is not pre-populated. And another thing, there is no way to clear the location. Now, what you could do technically is that once it's run, you could probably reset it back, I don't know, to null again. So let's say after every get forecast, once it's successful or whether it's not successful, we can call, editor config and say null. So technically you have to refetch it every single time. But then, you have to be careful with your code because, your select, if you try to run it again, it'll be null, so you have to reselect it again. And then this is how you structure your Angular application. This is something you have a complete control with the editor. You're not being forced to do it one way, but rather you're given a flexibility to do it any way you want. I suppose the purpose of this demo is more not to show you how to structure everything in terms of UI or controllers or components. Ideally you probably have to have a search component defined separately inside the editor, and you can do that. That's not an issue. It's, more of to get you the idea of how to work with it. So as you've seen yourself, working with the editor is very simple. So anytime you call update, what happens inside is essentially it runs the change. Well, it's not change detection. It's more of a diff. So it calculates the changes between the old data and new data, and then it notifies everyone about what has modified, So it works very well, especially for the global configs. So instead of you returning you an entire new object, it only returns you what was changed. And, you can act accordingly rather than re-update everything just because, you got one notification saying, oh, everything changed. So this way, you have more granular control of, okay, I'm updating this because location changed. And then if something else changed, I'm updating something else. So for example, here you could, have saved location, but then maybe you could have saved a very particular date you're interested in. And you see, because the weather component, the editor component of the weather thing has its own config, we can actually pre-save it in here as well. So if we search for Dublin, select forecast, get forecast, we have all our nice widgets. And then if you go save restore, it'll restore back and it'll work for this one as well. Now, notice this one small thing that it says undefined, and this is because in our mapping provider, we haven't actually provided a label for our data set. So we can maybe go back and quickly do that. So in here, we have to provide a label. We should probably call it a temperature. So yeah, this looks better. Now, so this is essentially a very kind of fast intro of how to develop a view provider. And I suppose, considering you coming from the engineering background, you should be able, just to follow along as I define everything. And I'd say the hardest thing for you would be to understand, if you're not familiar with Angular, to trying to understand how everything is, the services, modules, and so on and so forth. But other than that, it should be pretty straightforward. And the idea is, as well as having this video, we're probably going to work on the documentation as well. So you can refer and you can actually say, okay, what are the fields? What is the typical example of, let's say, a mapping provider? What are the fields for the declaration files? Or for example, what are the fields available to the editors? All of that probably should be written out in a document, and we'll do it at some stage. But this video was more about, trying to get you familiar of how would you do it? How would you do, let's say, a data provider or view provider or a mapping provider? So in this tutorial, we actually have done all the three main components, and we actually done the editor. The only thing we haven't done is the editor for the view provider. But then again, suppose for the weather widget, there isn't much you can modify. Maybe you could change the icons or something, something very small. I don't know, maybe you can, rearrange the layout or something, make these things go red. It's up to you. You can easily define it, but it's important to keep in mind that in view provider, you should only touch the view provider related configuration. So, if anything related, let's say with colors or text size or, whatever is view provider related, I suppose, it's different on case to case basis. Whereas with data provider, it's more to build your query to fetch your initial data. So let's say in the case of Neon, I need the table names, fields, and everything before I can send my actual final query, which will return me some data. And, this is only to get you kind of started. This is a very simplistic example. If you want to look for something complex and something more advanced, you probably should look inside the Neon, how I structured Neon. And, considering that this is what you're going to be using for the, rest of the duration of the project for most of the SC1s, SC2, whatever, you can extend that class, you can add, more functionality, but at least you have something to refer to. So look, I hope this was helpful for you. Maybe it'll help to clarify some of the things. And I mean, I kind of tried to walk through everything as much as I can. Now, some of the Angular specific stuff, I didn't go into details like observables and everything because, you could probably create another series of tutorials just on that. So if you have any more questions, you can get in touch with me or Sol. Just send us an email and, we'll try to explain you things. And then, as I said before, we're going to work on the documentation. So, maybe we'll be able to give some better examples and some better examples in a way that you can refer to them quicker, because probably jumping through the video back and forth would be very efficient. So that's it, guys. Thank you for your attention. I hope you watched it to the end. And as I said, if you have any questions, just let me know.